All right. All right, good afternoon, everyone. We are going to get started, or we're going to pick up where we left off. And before spring break, I hope everyone had a good spring break, by the way. We'll start with a quick review. We're talking about repetition or iteration. And we spent some time talking about for loop. What is this idea? Well, it's the idea that we have the ability to potentially repeat a task or a group of tasks until we meet some kind of terminating condition. We gave an example and we talked about the different types of loops. There are two, for loops and while loops. And they both have their purpose. Right? So for loops are intended to be used when you know how many times you're going to repeat something. So I know I'm going to do something X amount of times, let's use a for loop, or I have the ability to calculate it. So maybe I don't know an exact number, but I can programmatically calculate that number. And while loops are typically used when you have no idea how many times you want something to repeat. Maybe I do, maybe I don't. I don't know when I want it to stop. And then of course the do while loop is a variation of the while loop that makes sure it guarantees the instructions happen at least one time, right? We don't have a guarantee for the other two. For the for loop or the while loop, there's no guarantee that it will run at least once. If that condition fails, then it doesn't execute. It's kind of like an if statement. We looked at a couple of for loops examples, did some practice, and here we are with while loops. Now, a while loop actually, except for the word while, looks exactly like an if statement. It's the word while followed by some Boolean expression, and then in between the brackets, we have the instructions that we want to execute. And these instructions will continue to execute as long as that is true. So it's similar to a for loop in that it's going to evaluate this multiple times, but with a while loop, the first thing we're going to do is test this condition. Is it true? If it's true, I'll execute all these instructions, and then I'll look at the condition again. Is it still true? Oh, yes, it is. Well, let's do it again. Is it still true? Yes, it is. And we'll just keep executing this until that becomes false. Just like a for loop, it is possible to do things like this, right? We know one is true, so this condition is never going to become false. And of course, we never want to put the semicolon after the end of a for or a while statement, right? Or even an if statement, because that immediately terminates that statement by giving it an instruction, a blank instruction. So here's a better example of how you might use a while loop. So in this very simple piece of code here, we have, we're using the Boolean library, the standard Boolean library. We're going to create a variable called while condition. We'll set it equal to true. And then as long as this condition is set to true, we're going to keep repeating these instructions. What are we going to do? Well, here we have some variable. I'm going to scan for user input. And as long as you don't type 0, I'm not going to do anything. As soon as you type 0, here we're going to check that variable. And what is 0? If we attempt to evaluate 0 as a Boolean expression, what is 0? 0 is false. What does the exclamation point do? It inverts it, right? So instead of false, it makes it true. So if you enter 0, this will become true, and I'm going to change this variable to false. So that'll make us exit the loop. Right? So I don't know how many times you're going to type a number in. I don't know when you're going to type 0. Right? Initially, it's going to be true. So just because of the nature of how we wrote it, it's going to at least execute these instructions once. But aside from that, I have no idea how many times you're going to type in some random number besides 0. Right. So again, while loop, how many times do we run? I don't know. Until you type 0, that's when I'm going to stop. So we have a couple of questions here. Let's take a look at the code. And what do we think would happen? So here we have this declaration for this integer variable, keep going. What do we think would happen if we moved that outside of the while loop? Let's say we moved it down here. So look at the code. Let's try to understand the code. And what do we think would happen if we move this variable declaration outside of the while loop? Yes. That's correct. So if we move it to the bottom, it's going to be undeclared. It won't exist. Now, what if we moved it up here? So remember, we talked about scope and how functions have their own unique scope. How does it work for these types of things? How do we say it works for these types of things? There you go. So actually, performance-wise, it would have a nice benefit in that I only declare it once. As it stands, what's going to happen every time I execute this loop? I'm going to recreate this variable. So if we were to dig a little bit, what that means from the computer's perspective is I need to go find a blank spot in memory, allocate memory, point to that spot, and then when I'm done, I need to release it. And as soon as I repeat, I got to do it again. So every time I repeat, I have to do that. Versus if we were to move it up here, I only have to do it one time, and then I just reuse it as many times as I want. And unlike functions, if you're in the same piece of code, you can access variables declared above you within the body of a while loop or an if statement. We kind of addressed question 2 already. Very good. So the way it's written right now, here it is. What if right down here below these brackets, I just tried to print the value of keep going? I know it's a number. It's going to have some number in it, right? So what if I tried to print it right here? What do we think would happen? So let's pretend that the last time, well, of course, we had to type 0 to get out of here, right? So the value, we know that what the value is going to be if we're on this line, it's going to be 0. What if we just tried to print it? That is correct. So in this regard, it's kind of like function. So if you made the variable outside of this block, we can look at this. If you draw a box around this, we can look at this as a, we'll call it a block of code. If you made the variable outside of this block of code, you can access it inside, but not the other way around. In that case, whatever you make in here, if you created it in here, it only exists inside this box. It's kind of like functions in that regard. Once you leave this block, these things don't exist anymore if you created them in here. So because of the way it's written, once I leave the function, that variable doesn't exist anymore. So on the other hand, we have the performance benefit, right? Where we could create the variable here and we could reuse it. We don't have to keep recreating it all the time, but that variable is still accessible when we leave here. So if we don't want that information to be available, then it might actually be better to make the variable in here, even though we're going to have that performance hit where we're going to recreate it many, many times. When we leave, it's going to be gone, and nobody will have the ability to access whatever that information was again once we leave it. So very good. And then is it possible to nest? Let me ask this. Does anyone remember what that word means? To nest something, nest loops? That's right, to write another loop or a for loop or something inside of here. And absolutely, yes, you can. So if you want to, inside the while loop, you can have another while loop. And inside that one, you can have another while loop or another for loop. And they will always behave the same way. This one will run until it's done. If you have another while loop right here, you will stay right there on that line until that while loop is finished executing, and then you'll repeat that process. So do while loop is similar to a while loop. The only difference is your while and your condition go at the bottom, and you actually do need a semicolon for this one. So you do want a semicolon for this version of the while loop. You start with the word do, followed by the brackets and the instructions, and then you have your condition at the bottom. So this just guarantees that all of those instructions get executed at least one time. At least I do everything once, and then I evaluate the condition. If it's false, I don't do it again. But if it's true, then I'll just behave like a regular while loop from that point forward. All right. Two keywords that I don't believe we have gone over yet. Well, one of them we have, right? Break. When did we see break previously? Where have we seen that before? Switch statements, that's right. And break was what we used to get out of the switch statement, right? It behaves the same way for loops. So for loops, you can use breaks to exit the loop. So if, let's say we have a for loop and I want to execute this loop 10 times. So I equals 0, I is less than 10. As soon as I hit that break statement, I'm done with the loop. I just completely exit the loop and I start executing other instructions below the loop. Same thing for a while loop. So break exits a loop. It's kind of like return. So for functions, we can use the return keyword and it will immediately exit a function, plus it'll return a value potentially. Well, the break will immediately exit a loop. Continue is kind of like that, except it doesn't exit loop, it just skips to the next iteration of the loop. Let's take a look at an example. So, well, I wanted to ask the question, so I won't look at an example yet. I'll try to explain it better and then we'll ask the question. So continue, if we have a loop, let's say I is from 0 to 10. I equals 0, I start executing instructions, and here is my continue instruction. It's just like break, it's just a word and a semicolon. If there are any instructions below that line, we just skip it. I don't even execute those instructions. I go back to the top and I is 1. I come here, what happens? I skip everything below it and I is 2. So that's all continue does. Continue doesn't exit the loop, but it ignores every instruction below it and it skips to the next iteration, whatever the next iteration is. While loops, of course, we typically don't have counters, but it behaves the same way. If it's repeating, then the continue will ignore everything else and immediately evaluate the expression again. And if you get to the continue again, you'll just keep doing that. Now, if we take a look at this piece of code, let's try to, not even going to say anything. In the past, this screamed at me. Remember, this made a really weird noise the first time it did that. And I recognized it, but it's never done it again. I wish it would. I'm sorry, online students, my projector cut off again. Give me 45 seconds and we can continue. In the meantime, while we're waiting, if you have your computer with you, you can go ahead and open up JGraph because we're going to do an exercise in a minute. All right, so let's take a look at this code here. So we have a loop. We understand that loop is going to iterate 10 times, right? I will have values 0 through 9. And here's our code. So I mod 2, remember what we said modulus did? It'll divide the first number by the second number, and it will return the remainder. So if there's a remainder, that's what the answer is going to be. So if I mod 2, and remember how if statements work, 0 is false, anything else is true. So if I mod 2, if it's an odd number, this is true. And then here we have a print statement. So looking at this code, what do we think is going to get printed? What do we think? Somebody knew. What do we think is going to get printed? I see 2 halfway raised hands. Does one of you want to give it a try? Okay, go ahead. Yeah, Auburn sweatshirt, yes.
All right, so this could be wrong, of course, but I guess everyone better get it wrong, just not try.
There you go.
So I believe it's going to for this loop is going to run it in each case, and as it goes through, and if it is odd, then it will continue, and if it is not, then it will go back to the top of the loop. Is that incorrect?
Okay, well that's how it's going to behave, but what is it going to print? Is it going to print anything at all? So there's a print statement right here. So how is that word going to affect that print statement? What's going to get printed? You described it correctly, but
so it will print just the first case period, right?
So we have to look at a couple of things, how if statements behave. So we don't have brackets here. So what does that mean? Which of these instructions belongs to the if statement?
It means everything underneath the if statement.
That's not true. Remember, if we don't use brackets, how many instructions belong to the if statement? Just one, just the next instruction. So which instruction belongs to the if statement? Continue. So continue is only going to get executed every time that's true. So when is that going to be true?
Only if it's odd.
It's going to be true for every odd number. So for every odd number, we're going to execute that continue statement. What does continue do? It goes to the next iteration. So we're going to skip this instruction. But if this is false, what are we not going to do?
It's not going to check the odd.
If it's false, we're not going to execute the continue instruction, right? And we're going to print whatever I is. So what is this going to print? 0 is considered an even number. So yeah, 0, 2, 4, 6, 8.
So then it would say I is 0.
I is 0, and then it would print I is 2, and I is 4, and I is 6, and I is 8. So it would print all the even numbers. E0 is considered even as far as this is concerned. Right? Very good. So that's what the continue will do. Again, it's not going to exit the loop. We're still going to keep executing the instructions, but every time I execute this instruction, I'm going to skip everything below it, go back to the top, and go to the next iteration. So I won't be 0 anymore. It'll be 1, and then 2, and then 3. Break, let's take a look at this one. What if we changed it to look like this? So we only made one change. We put break instead of odd here, break instead of continue here. What do we think is going to get printed now?
This would be what we initially intended it to be, correct?
Well, we didn't really have any intention initially. We just, you know.
Because if this exits true, then break, and
So this is an if statement. If this is true, so I mod 2, it's going to take this number divided by 2. And if there is any remainder, it's going to return it. If it returns a remainder, that's going to be interpreted as true, right? So the only time you're going to have a remainder is for any odd number, right? Every odd number, if you divide it by 2, it's going to have a remainder of 1. For every even number, the remainder is going to be 0. 0 is false, right? So if this is false, I'm not going to execute this instruction here. If this is true, I am going to execute this instruction. What does break do? Break exits. It's kind of like the return for function. It exits the loop completely. So let's just run through. If 0 mod 2 is going to be what, true or false? False, because 0 divided by 2 has no remainder. So we would print I as 0. We'll go to the next iteration. I is 1. 1 mod 2 is what? So it's true. Now what are we going to do? We're breaking, we're over. What's going to print I as 0, right? It'll print that first one. Very good. So now let us do a brief exercise. Hopefully we have time to do at least some of it. We've done this type of thing several times. Oh, I see. I was not, sorry, online student. I wasn't paying attention. Very good. That is correct. Let's take a look at this exercise here. And here's what I want us to do. Now we've done something like this already. We want to write functions that can calculate the minimum, maximum, and medium of 4 numbers. So you have to give it the 4 parameters. You have to give it the 4 numbers. So you're going to write a function that has 4 parameters. And that function should have the ability to return. If I give you 4 numbers, I can give you the smallest one, the biggest one, and whatever the median is. Then I want you to write in your main, I want you to use those functions and prompt the user for inputs. But here's what I want you to do. Every time they enter a number, I want you to check to see if they already entered that number. So if they entered 1 and 1, you should say, oh, you can't give me a 1. You already gave me 1. You got to give me a different number. And if they type a 1 again, you should tell them again, you can't give me that number. You already gave me a 1. And you should keep doing that until they give you a different number. So you want the user to enter 4 unique numbers. That way you can meet your preconditions. So this is the one thing that we have that we didn't have before. I got a precondition now. This function will behave correctly as long as you don't give me any repeated numbers. Same thing for all of them. So how do we guarantee that? Well, we can guarantee that when we accept the numbers, I can check the numbers you give me and make sure you didn't repeat any values. Any questions? Then good luck. And I'm here if you have questions for me. Yes. Let's go ahead and do some of this together. We'll at least get that skeleton done, right? Let's try to at least do that. So let's do here. We'll just do everything in one file. I know I need this. I probably want to print stuff. And then we'll make our, let's just assume they're all going to be whole numbers. So we'll do, we need to return a number, right? So we'll just say, we'll call this one min. And I need to accept 4 whole numbers. So how do I say that in my function definition? That I need you to give me 4 whole numbers so that I can work correctly. Very good. And then just 4 times, right? You're going to have 4 variable declarations. Now I can accept 4 numbers. I can return something. We'll just return 0. So there's our stub. And we're going to do something similar for the rest of these, right? So what does this do? Given 4 numbers, returns the smallest one. Given 4 numbers, returns the largest one. And we'll do the same thing, int max 1, 2, 3. And we just need the logic for that. And then here, given 4 numbers, returns the median. And we already have double median, and we'll just say and then of course we do need our main. So we'll just say test our functions. And don't have anything in here right now. So there's our skeleton, right? We at least need this stuff. Let's try to do this first one together. How could we solve this problem here? If I have 4 numbers, here are my 4 numbers. How do I determine which one is the smallest one and give that back to you? How could I do that? If we think about it, not from the computer's standpoint, but just logically, I know I need to look at all the numbers first, right? And I need a way to remember which one is the smallest number. So now thinking about it from a programming perspective, with that in mind, I need to look at the numbers and I need to remember which one is the smallest numbers. What are some C programming tools we can use to make that happen, to enable those things? Go ahead. Okay, if N1 is less than N2, what do I do? Huh? So how do I keep it? Or we don't really keep or throw anything away, right? These all have values and I'm able to access them between these brackets. And one of these is going to be the smallest value, and I want to return that one. Okay, so we could make a whole bunch of if statements. And we can make 4 different if statements to test every possibility, whether one of these is the smallest ones. Okay, what else could we do? We could do that. That's possible. So if it's smaller than that, and N1 is less than N3, and N1 is less than N4, then we return N1, right? And then we'd have to do that for 2, 3, and 4. Is there another option? This is not a bad one, but is there another option? Because we could potentially make lots of comparisons here, right? How do we remember stuff? So here we're actually doing it without having to remember. We're just going to look at it and make a decision right away. What's that? There we go. So variables allow us to remember things, right? That's how we save information. So we can make a variable, maybe called smallest. And initially we just set it equal to the first. We just randomly pick one. We just pick N1. And now we can do something like what we just did. If N2 is less than smallest, what can we do? Well, we have a new value for smallest now. And we can do, we'll just do the same thing. Else if N3 is less than smallest, smallest equals N3, else if N4 is less than smallest, smallest equals N4, and then we can just return whatever that is, right, when we're done. And we could do something similar for this one, right? What would we need to change? Let's just copy this. What would I need to change to make this work for this other function here that says max? That's right. So let's do this, and we're just going to change these signs. So we'll do, I should have just called it number. Then I wouldn't have to write so many. You can just change the signs to bigger. And median, what can we do? We'll go ahead and give, because I really want y'all to work on the while loop part. Median, we can do, it's pretty straightforward. Let's just do N1 plus N2 plus N3 plus N4 minus the biggest and the smallest one, right? So we can say min minus max let's do this so it's a little more legible. So if we take all 4 of these numbers and subtract the biggest and the smallest 2, we should be left with the two middle values, right? And then we can just divide those two middle values by 2, and that should give us the median. So there goes our median. Now, how do we test our function? What are we going to do here? This is the part I want us to work on. So we have this code here. Let's do this. So what I would like us to be working on now is this part in the main here. How do I write that part in the main? Where I need to ask you for 4 numbers, but I want to make sure you give me 4 unique numbers. So remember, you're going to have to prompt the user. How do we do that? Or how do we know how to do that so far? What's the only way we really know how to do that? There we go, print statement. The user going to type something and we need to capture that and save it. How do we do that? Scanf, and we need variables, right? And then we need some type of loop that will guarantee you don't give me any duplicate values, loops and if statements. So let's work on that part. And actually, we don't really need, does anyone still need this, or have we done this already? Can I get rid of this stuff? There we go. Bless you. So let's take a look at one use case. Here, if you look at the projector, you can see that we've got the first number. We don't really need to check anything for the first number. It's going to be unique because it's the first number we've gotten. But time for the next number. Please enter another unique whole number. And let's do, we know at least we need to do this. But of course, this isn't going to be enough. Now, how do I guarantee that the number you give me is going to be unique? What can I do? How can I at least check? What can I do to at least check that you gave me a unique number? Yes.
You can probably do something like an if statement just to check if values are equal.
Okay.
And
So,
if they are equal, then that would be, and then we say in that true case, something to the effect of these prints, these are not unique numbers.
okay. So if this is true,
And we'll obviously we'll need an else, so we could say to continue to enter a separate number as well.
why don't we just copy this? Because I'm lazy and I don't want to write. We can just print the same thing. Hey, please enter a unique number. And actually, we could just do this again too, right? Because if you gave me a non-unique number, I can just ask you again, hey, give me a unique number and just override the value of that variable. So previously I had a value in N2 that was a duplicate. Now you give me another number and I save it in there. So that'll work for the first attempt. But what if I type another copy, the same number again? I type 3, 3, and then I typed in a 3 again. How do we fix that problem? So we fixed the problem where you type 2 3s. How do we fix the problem? What if we type 3 times, you type the number 3, then what do we do? How can we modify this so that will catch that? What can we change or add to this so that it will behave the way we want it to? Anyone? So what do we want to do? What's our goal? Our goal is to get 4 unique numbers, right? And we're going to do it one number at a time. So the first number, we already know it's unique. It's the only number you've entered. The second number, we have to compare it to the first, make sure they're not the same. And if they are the same, I have to ask you again to give me another whole number. But you could, theoretically, you could type the same number in again. So what do I do if that happens? How do I write the code? How do I write the computer code that solves that problem? What if you keep giving me the wrong number? What can I do?
That'd be where we want to just do a loop.
What kind of loop do you think we should use for that?
We could use, well, it wouldn't be the first type of repetition, it'd be the second one. Wait, but the classifications, I need to.
The one we learned about today, right?
I don't get this wrong.
It's a while loop. That's right. The one we learned about today. Very good. And how can we change this to a while loop? We could delete the word if and write the word while. Very good. So change that to a while loop. What do we say? What do we say a while loop? Well, you can look at it like a repeating if statement, right? And if we think about this now, what is this going to do? Initially, we're going to scan for this number, and then we're going to compare these two values. And if they're equal, I'm going to ask you for another number, and I'm going to scan again. And I'll keep doing that until that's not true anymore. And then we'll exit the loop. Now, what if I didn't want to write this 2 times? Because we really wrote this 2 times, right? Is there anything we could do to cut down even more on how much we have to write? because programming is about being lazy. I want to type as little as possible, right? That is a great program if I don't have to type too much. How do I do that? How do I remove even more from this? What can I do? Is there another kind of loop we could use?
For the first section, can we use a for loop?
We don't want to use a for loop. A for loop's not going to be, you could do it in a for loop, but that's not going to be appropriate here. Remember, you can use for loops and while loops interchangeably as long as you get the syntax right. We could use a do while loop, because what does a do while loop guarantee? It guarantees it gets executed at least once. So instead of having this condition here, let's X that. We can put it here with a semicolon, and at the very beginning of this, we can just write the word do. Very good. So now we've removed even more. We guarantee this is going to run once. I need it to happen at least one time. And then as long as those two things aren't equal, we're done. We're finished. But if they are equal, then we'll continue repeating until they're not. And we can do the same thing for the next two numbers, right? So do, actually, let's just copy this. And now, of course, we want to do number 3. And what are we checking now? Now we want to make, we already know the first two are unique. That's right. We could really check, well, we have to check both of them, right? So number 1 can't equal that. And number 2 can't equal that, right? It has to be completely unique. It has to be different from number 1, and it has to be different from number 2. But we'll keep repeating it. We can do the same thing for the last one, right? We'll do this for N4, and we'll just change this to 4, 4. So if, oh, what do we think? Is this going to work correctly, or do we want to try it out and see? Let's do this and we can just print the 4 values that we got. So what do we think? It's going to compile. It's not syntactically incorrect. Is it going to run correctly? Is it going to behave like we think it should? Anyone? All right, let's run it and see. So enter a whole number. Let's do I'm trying to, okay, well. There we go. So this, we'll do 2. So enter another number, 2, 2, 2. Okay, so it won't let me, it's gonna keep asking me, so we'll do 3. And then we'll do 3. Oh, wait a minute. What happened here? Why did it let me enter 3 so many times? It worked the first time. What's different about these two that caused it to allow me to enter the same number multiple times? What's that? Very good. I think you're all kind of saying the same thing. We're asking the wrong question. I should be asking if it's different than this one or if it's different than that one. As long as one of those things, N1 has to be, as long as it's different than this, or as long as it's not the same as that, or it's not the same as that, it has to be different than both of them, that's fine. But instead I said it has to be equal to all of those things, right? Actually, wait a minute. If N1, oh, actually, this is okay. Well, let's change it to the or and let's see this. Let's see what happens here, right? So now we're saying something different. We'll test a couple of variations. So now what we're saying is this what you all are saying? Change it to or. So now we're saying if number 1 is equal to 3, or if number 2 is equal to 3, I'll repeat this again. So let's try that. So if any of these things is true, I'll repeat again. And we'll do, let's do 2, 2, 2, 2, 2, 2. Okay, can't keep doing 2, 3. Oh, it's not letting me do 3. Very good. Very good. Nicely done. So the other thing we could have done is change this. So you all kind of hinted at this. The other thing we could have just changed this to not equal, right? As long as it's not equal to that and it's not equal to the other one. Or we'd have to change our logical expression. So unfortunately, I think we are out of time, but at least you have this much. I would encourage you to try to do the last part. Now that you have these 4 unique values, try to actually use them. Call these functions and use those and just see what values you get. So get some practice calling other functions. And if you don't have any questions for me, have a good day. On Wednesday, we're going to do a vocarium exercise. So if, I'll be here in class on Wednesday. We'll do those together. It'll be a graded exercise. And if we don't have any questions, I'll see you all on Wednesday.